It was the spring of 1952 when a convoy of black ZIS sedans wound its way through the muddy outskirts of Moscow toward a newly fenced compound bearing no sign and guarded by armed men in winter coats. Inside waited a group of physicists, meteorologists, and engineers, each summoned by direct order of the Council of Ministers. They stood before a long table where party officials spoke in measured tones about an idea so vast it bordered on myth. The Soviet Union, they declared, would learn to command the weather. To Stalin, still alive but already fading into legend, it was the ultimate expression of socialist mastery. The same hands that had conquered famine, built canals through permafrost, and split the atom would now bend the clouds themselves to human will. The premise was seductively simple. If rain could be called forth on demand, crops would never fail. If storms could be dispersed, entire regions might be tamed for settlement and production. Beneath the rhetoric lay a deeper ambition, the belief that nature, like society, could be planned. The empire's vastness had always been both blessing and curse, deserts in the south, floods in the east, and winters that swallowed armies. To control the sky was to eliminate weakness from geography itself. Research began under the banner of hydrometeorological optimization, a phrase that concealed more than it revealed. Laboratories in Leningrad and Novosibirsk received quiet funding to study cloud seeding, atmospheric ionization, and large-scale energy transfer between air masses. The press published patriotic features showing silver iodide generators mounted on aircraft, promising rain by request for the collective farms. In smoky lecture halls, young scientists dreamed aloud of rivers redirected by lightning rods and jet streams guided like invisible rails across Siberia. Yet behind the optimism lurked fear. Stalin's inner circle demanded results, and the line between research and failure could end in exile. Meteorologists who questioned the feasibility of total climate regulation risked denunciation for defeatism. One recalled later that the atmosphere became as political as the air we measured. Every chart, every barometric map, every hesitant report was framed as proof that the revolution extended even to the heavens. By late 1952, prototypes were already taking shape. Crews loaded experimental chemicals into small Antonov planes and flew sorties above the Volga basin, dispersing fine mist into gray winter clouds. Observers on the ground recorded modest snowfall where none had been forecast, and the newspapers trumpeted it as the first victory of human will over the sky. In truth, no one could prove whether the snow had come from science or coincidence. But in a country desperate for triumph, perception mattered more than meteorology. When the reports reached Stalin's office, the aging leader scrawled a single phrase in the margin: expand the experiment. Orders followed swiftly: establish a central institute for weather modification, recruit from the Academy of Sciences, and coordinate with the Red Air Force for logistical support. Overnight, the pursuit of understanding the climate became an operation of state importance. What began as scientific curiosity was now national doctrine. Outside, winter gripped Moscow in iron silence. From the frozen streets rose the smoke of a nation that believed nothing in the world was beyond control. The scientists working behind those compound walls had no way of knowing that their quest to master the clouds would one day spiral into a secret campaign spanning continents, costing fortunes, and leaving questions that no forecast could ever answer. By the early 1950s, Soviet science lived in a paradox. It was both liberated by ambition and suffocated by politics. The death of Stalin in 1953 did not extinguish the dream of mastering nature, it simply transferred that dream to a new generation of technocrats who believed they could engineer the planet the same way they built hydroelectric dams or five-year plans. In their eyes, the atmosphere was a vast machine, a system of pressure, temperature, and motion waiting to be tuned. All that was missing were the right instruments and the will to use them. In Moscow's main geophysical observatory, maps of wind currents hung like battle charts. Teams of young mathematicians, many fresh from the war, worked late into the night calculating the behavior of clouds with slide rules and logarithmic tables. They spoke in the language of power, control coefficients, atmospheric thresholds, manipulation potential. Every storm was a problem to be solved, every drought a technical error awaiting correction. Comrade, one senior researcher wrote, "The weather is only chaos until it is planned." Under the new administration of Nikita Khrushchev, the spirit of optimism reached a fever pitch. The party envisioned vast agricultural reforms and needed science to make the land obedient. The Virgin Lands campaign would transform the steppes of Kazakhstan and Siberia into fertile grain fields. But the climate was merciless, scorching summers, dust storms, and long droughts. Thus the weather scientists, once seen as mere observers, suddenly became the engineers of Soviet destiny. Their orders were clear: make it rain. Planes were fitted with chemical dispersal pods. Rockets were loaded with silver iodide cartridges. Mobile cloud regulation units were dispatched to remote airfields. Soviet newsreels showed pilots releasing puffs of vapor into towering thunderheads, accompanied by triumphant orchestral music. Commentators spoke of a sky no longer free, but loyal to the hand of progress. Western meteorologists, watching through intelligence reports, were astonished by the scale of these operations. The early trials were inconclusive but dramatic. In 1955, near Alma-Ata, observers recorded a storm that formed unexpectedly after an aircraft release test. To party newspapers, it was evidence of success. To the scientists involved, it was a mystery. They had no precise model explaining why one cloud reacted and another did not. But the political machine demanded certainty, not hesitation. Soon, every rainfall was declared a victory of Soviet technology, and every drought was blamed on insufficient enthusiasm or sabotage of the hydrometeorological effort. Behind the propaganda, however, real progress was taking shape. Soviet physicists developed primitive but functional methods of atmospheric electrical measurement. They began exploring how static charge and ion distribution influence precipitation. The Institute of Atmospheric Physics, newly established under the Academy of Sciences, became the center of this pursuit. Within its walls, men like Yuri Israel and Mikhail Boudicco debated whether Earth's climate could be stabilized through deliberate human interference, whether global temperature could be adjusted like a thermostat through aerosols and radiation balance. Their discussions were confidential but visionary. By the late 1950s, the Soviet Union possessed more data on upper atmosphere behavior than any other nation on Earth. High-altitude balloons, sounding rockets, and polar expeditions provided a torrent of information. To Khrushchev's planners, this knowledge hinted at the ultimate possibility: geoengineering, the conscious design of Earth's environment. It was not yet called that, but the dream was unmistakable. Still, the scientists faced a haunting question. Each experiment showed that the atmosphere was more complex than any machine: chaotic, non-linear, sensitive to the smallest variation. For every successful rainfall, another experiment brought floods, or none at all. In private diaries, some researchers began to express doubt. One wrote, "We can summon the rain, but we cannot yet dismiss it." In public, those doubts were never voiced. Khrushchev demanded results, and results he would have. The Soviet Union had launched its first artificial satellite. Surely, they reasoned, controlling the clouds would be simpler than reaching the stars. The next stage would demand something bigger, louder, and far riskier than aircraft dispersal or silver iodide. By 1957, the idea of commanding rain had grown from scientific speculation into a state-sponsored obsession. Soviet radio broadcasts celebrated the coming age of weather by decree, and posters appeared in factory halls depicting farmers beneath clouds marked with the red star, rain falling in symmetrical lines across the fields. The message was clear: the Communist Party had mastered not just the earth, but the sky itself. To millions of citizens, weary from years of famine and scarcity, it was a promise of abundance finally guaranteed by science. The heart of this vision lay in cloud seeding, a technique born from American research but adopted and expanded in the Soviet way, massive, centralized, and secretive. At its simplest, the method relied on releasing microscopic particles, usually silver iodide, dry ice, or salt, into clouds to trigger condensation. In theory, this encouraged raindrop formation and increased precipitation. In practice, the results were chaotic. Clouds ignored ideology, they formed, dispersed, and shifted according to laws that even the best meteorologists barely understood. But for the men in Moscow, the ambiguity didn't matter. What mattered was control, or at least the appearance of it. Khrushchev's agricultural planners demanded demonstrations. Across the plains of Ukraine and Kazakhstan, squadrons of Antonov and Ilyushin aircraft were deployed for experimental meteorological flights. These operations were often conducted without public explanation. Farmers would look up to see silver trails spiraling from low-flying planes, followed hours later by heavy rain, or sometimes by hail and lightning that shattered crops. Reports sent to Moscow praised the success rate, though field commanders quietly altered data to avoid punishment. The experiment had become an institution, a self-perpetuating belief that if the results were inconsistent, the fault lay not in the science but in the effort. Meanwhile, Soviet television showcased what it called rain brigades, teams of scientists and pilots armed with flares, canisters, and optimism. Children's magazines printed simplified diagrams showing how rain engineers helped nature bloom. The illusion worked. Collective farms began submitting petitions requesting local weather modification units, as if rain could be scheduled alongside fertilizer deliveries. Regional committees even competed for the highest precipitation success index, a meaningless metric invented to impress Moscow. But within the laboratories, doubts were growing. Senior researchers observed that repeated seeding might actually reduce rainfall in neighboring regions by draining clouds too early. Others worried about chemical residues falling on crops and rivers. Some experiments appeared to alter storm tracks in unpredictable ways. A classified 1958 memo from the Ministry of Agriculture admitted significant interference effects not aligned with planned outcomes, a careful bureaucratic way of saying the experiments were sometimes catastrophic. Still, the political momentum was unstoppable. In 1959, the Soviet Union unveiled its state program for climate regulation, an ambitious 5-year plan to expand cloud seeding across multiple republics. The project's budget rivaled that of space research. Air Force squadrons were assigned to meteorological support, and weather modification centers sprang up from the Caucasus to the Arctic. Each was equipped with radar, chemical storage, and aircraft refueling stations, all under strict military supervision. One of the most daring undertakings took place near the Aral Sea, where scientists attempted to redirect atmospheric moisture toward the desert basin. Their goal was to transform the barren region into an oasis of grain. At first, results seemed promising, brief rains greened the steppe, but the unintended consequences soon followed. Wind shifted, rainfall patterns changed, and within months, floods devastated towns hundreds of kilometers away. The project was quietly classified, the data sealed, and the public narrative rewritten into triumph. Through all this, Khrushchev remained an ardent believer. To him, controlling the weather was proof that communism could conquer nature's last unpredictability. He once declared at a party meeting, "We will grow wheat where the devil himself could not." The audience applauded, unaware that behind those words lay a mounting chain of failures hidden under layers of secrecy and pride. By the dawn of the 1960s, the dream had hardened into doctrine. The scientists, pressured to perform miracles, turned to even stranger ideas: electric charges, magnetic pulses, and high-atmosphere ionization. The belief was that if clouds could not be persuaded, they could be commanded. The rain would no longer be coaxed from nature, it would be forced. The 1960s opened with the hum of optimism and the crackle of electricity. In laboratories from Moscow to Novosibirsk, Soviet scientists began to view the sky not as an untouchable dome of air, but as a vast electrical circuit, a network of charge, current, and polarity that could, in theory, be altered by human technology. The concept was intoxicating. If lightning could be guided, if the ionosphere could be nudged, then weather itself could be designed. The idea became known simply as atmospheric ionization control. It was a strange blend of physics and fantasy. The atmosphere, researchers argued, was charged with billions of volts of natural electricity. If this could be manipulated by discharging rockets, tethered balloons, or ground-based transmitters, storms might be dispersed, rainfall enhanced, or fog instantly cleared. In theory, it was a direct line of communication with the heavens. In practice, it meant building machines powerful enough to rival nature's own voltage. The experiments began quietly under the Institute for High Voltage Research, a branch of the Soviet Academy of Sciences. At the edge of Moscow, an enormous steel tower was erected, bristling with antennas and copper spheres. It looked less like a scientific instrument than a weapon. Technicians called it the lightning harp. When activated, it sent pulses of artificial charge into the sky, followed by long, eerie rumbles of thunder that rolled across the city outskirts. Officially, the project's purpose was electrostatic discharge testing for atmospheric purification. In reality, it was a test of human dominion over storms. Elsewhere, in the Cuban region, mobile ion generators were deployed across the steppe. These were crude, tractor-sized devices that burned metallic compounds to release charged aerosols into the air. Farmers watched black smoke rise from the machines as engineers recorded data on wind direction and humidity. Within hours, clouds formed where there had been none. Local newspapers hailed the event as scientific sorcery, a phrase that made party officials uneasy but captured the mood perfectly. As the technology scaled, so did its ambitions. The Ministry of Defense quietly entered the picture, intrigued by the potential military applications. Reports circulated that thunderstorms could be weakened before military parades, or fog cleared for air operations. Even more tantalizing was the possibility of disrupting enemy weather, creating rain in one region to cause drought in another. The science was thin, but the imagination was boundless. One particular site, hidden in the Ural Mountains, became central to these trials. Engineers built what they called a controlled lightning field, a grid of tall masts connected to underground capacitors. During tests, the array discharged enormous electric arcs into the air, sometimes triggering real lightning from passing clouds. Witnesses described the ground shaking, the air metallic, the light searing white. A few photographs, long since declassified, show blinding columns of fire stabbing upward into dark clouds. To Western intelligence analysts who later studied them, it looked less like meteorology and more like science fiction. The scientists themselves were divided. Some believed they were on the verge of unlocking the key to climate regulation. Others warned that the system was too chaotic to be safely manipulated. One engineer later recalled, "We tried to tame the sky with the tools of Prometheus. We forgot that he, too, was punished." Still, the results were compelling enough to justify expansion. By 1964, the Electric Sky Initiative, as it was internally known, received new funding directly from the Central Committee. The rhetoric shifted from research to implementation. State planners envisioned entire weather control corridors stretching from the Black Sea to the Urals, where electric towers and ground-based ionizers would regulate rainfall for agriculture and industry. Yet for every apparent success, strange anomalies began to appear. Radio interference disrupted communication across test zones. Aircraft reported turbulence and static discharges near experimental towers. In some towns, animals panicked during activation cycles, and locals spoke of invisible storms that appeared without warning. Data logs grew inconsistent. The more the scientists measured, the less predictable the results became. By the late 1960s, the optimism of the electric sky was fading. The equipment corroded, the budgets shrank, and the scientists who once promised dominion now spoke cautiously of atmospheric perturbations. The dream of total control had collided with the chaos of reality. But the project's failure did not end the ambition, it merely drove it deeper underground. Meanwhile, in the West, whispers began to spread of America's own atmospheric experiments, secret projects carried out under the guise of defense and research. Soviet intelligence took notice. If the Americans were tampering with the sky, then the race for climate supremacy had only just begun. By the middle of the 1960s, the Cold War had grown into something far stranger than an arms race. Rockets reached space, satellites watched every movement below, and both superpowers began to imagine warfare in domains no general had ever commanded: the oceans, the upper atmosphere, even the weather itself. For Soviet scientists, the discovery that their American counterparts were pursuing similar research transformed curiosity into urgency. What had once been a national dream was now a strategic necessity. The climate had become a battlefield. In Washington, classified programs with cryptic names, Project Storm Fury, Project Popeye, Skyfire, hinted at the same ambition that animated the Soviet efforts. American engineers had begun testing cloud seeding in the Caribbean to weaken hurricanes, and later in Southeast Asia, attempting to lengthen monsoon seasons over enemy supply routes. Officially, it was all research; unofficially, it was weaponization. The revelations alarmed Soviet intelligence. If the United States could direct rainfall to flood Vietnamese roads, what would stop them from freezing crops in Ukraine or flooding the Volga? The Kremlin feared not nature's wrath, but Washington's imagination. Reports filtered in through the GRU and KGB scientific directorates. Agents embedded in meteorological conferences returned with rumors of high-altitude aerosol experiments and chemical releases from military aircraft. American journals spoke innocently of environmental modification, but in Moscow, the term carried a darker resonance. The Politburo convened a secret session to discuss the potential hostile influence on Soviet weather systems. No evidence existed, but in the logic of the Cold War, absence of proof was never proof of absence. The response was immediate: expand domestic research, double budgets, and ensure that the Soviet Union would never be at the mercy of another nation's sky. Thus began what internal memos called the Atmospheric Defense Initiative, a shadow counterpart to the space race. Officially, its purpose was to understand how global circulation might affect agriculture and military logistics. In truth, it sought countermeasures against possible American climate aggression. Laboratories received new directives: simulate induced rainfall, model aerosol diffusion, test electromagnetic disruption of cloud systems. What emerged was less a single project than a web of overlapping efforts, each cloaked in secrecy, each convinced it was defending the motherland. In a remote Siberian research station, scientists launched hundreds of small weather rockets loaded with metallic dust designed to trace air currents. They studied how particles drifted, dispersed, and clustered, how an invisible chemical could reshape cloud behavior across vast distances. The findings were classified immediately. In Leningrad, radar specialists built new Doppler systems to monitor foreign seeding attempts, claiming to detect artificial cloud anomalies over the Baltic. Western historians later dismissed these as misread data. To the Soviets, they were signs of intrusion. The paranoia reached the highest levels of planning. By 1967, the Ministry of Defense began cataloging meteorological vulnerabilities alongside maps of missile silos and radar sites. Airfields were ordered to maintain emergency dispersal equipment to counteract localized precipitation sabotage. Entire divisions trained for weather warfare that no one could prove existed. Yet in this strange logic lay the essence of the era. If the enemy might one day control the weather, the only safety was to control it first. Behind closed doors, the competition bred innovation. Soviet climatologists advanced new computer simulations of atmospheric motion, pioneering early models that would later form the backbone of modern forecasting. Their goal, however, was not prediction, it was manipulation. They sought the keys to the planetary engine, the pressure zones, jet streams, and ocean currents that governed all weather. If these could be nudged, even slightly, an empire could alter its own fate. In 1968, a classified conference in Novosibirsk brought together physicists, generals, and party officials. The discussion was stark. Could atmospheric energy be used as a weapon? One proposal suggested detonating small thermonuclear devices high in the stratosphere to alter jet stream patterns. Another envisioned vast arrays of microwave transmitters projecting heat into storm systems. Most of these ideas were impossible, but they reflected a chilling shift from studying weather to using it. When the meeting ended, the participants left with a shared conviction: the race for the skies had entered a new phase. The enemy was not merely across the ocean, it was above it. The Soviet Union would have its answer, and it would bear a name whispered in laboratories for years to come: Project Cyclone. In the winter of 1969, a classified order left the offices of the Soviet Academy of Sciences under a bland bureaucratic title: on the coordination of research concerning the artificial regulation of atmospheric processes. Buried inside was a code name, Cyclone, and a directive stamped with the red seal of the Central Committee. Its stated purpose was to unify scattered experiments in weather modification. Its true goal was far bolder: to create a centralized system capable of manipulating regional climate on command. For the men who received the order, it was both an honor and a warning. Once assigned to Project Cyclone, there was no refusal, no failure, and no escape from secrecy. The project's headquarters was hidden in a nondescript complex outside Novosibirsk, disguised as an agricultural research facility. Inside, corridors buzzed with the sound of generators and the faint ozone tang of electrical discharge. Meteorologists, physicists, and engineers, many veterans of earlier weather experiments, worked under round-the-clock schedules. Their leader was academician Mikhail Budiko, a respected climatologist whose public writings spoke of planetary energy balance but whose private papers revealed something far more audacious: the dream of geoengineering. Budiko believed humanity could reshape Earth's climate through deliberate alteration of radiation and atmospheric chemistry. Under Cyclone, theory would meet state power. The first phase focused on ionosphere manipulation. Using ground-based transmitters and high-altitude rockets, scientists attempted to alter the upper layers of the atmosphere to influence weather formation below. The principle was primitive but plausible: inject charged particles, disturb local pressure gradients, and observe resulting shifts in cloud structure. Early tests over the steppes of Kazakhstan produced anomalies, thin cirrus sheets forming where clear skies had been predicted, sudden shifts in wind velocity, even the appearance of high-altitude electrical arcs visible to pilots hundreds of kilometers away. The data astonished the researchers and terrified the military observers overseeing them. One report described the experiments as opening a conversation with a power that does not answer in words. Funding multiplied. Laboratories expanded into former missile test ranges, where equipment could operate without public notice. Cargo planes carried hundreds of tons of silver iodide, barium salts, and conductive aerosols to remote bases. Engineers constructed weather towers, some over 100 meters tall, equipped with massive discharge coils designed to ionize the air over thousands of square kilometers. The ground around them was scorched black by repeated surges of current. The line between research and weapon grew thin. Cyclones documents referred to atmospheric control zones, regions where climate could theoretically be stabilized or destabilized depending on political or agricultural needs. One plan proposed directing storms toward drought areas, another, marked extreme measure, speculated about inducing torrential rainfall to hinder enemy troop movements. Most of these ideas never left the paper stage, but their inclusion revealed the mindset: nature had become an extension of statecraft. Boudico and his colleagues argued that if the US was conducting environmental modification warfare in Vietnam, reports of Operation Popeye had begun leaking by then the Soviet Union was obliged to master its own response. They insisted Cyclone was defensive, a shield against meteorological aggression. But not everyone agreed. Some senior scientists protested the militarization of climate science, warning that such manipulation could trigger chain reactions impossible to predict. Their letters were intercepted, their careers quietly ended. The program continued undisturbed. By 1971, Cyclone's reach extended across the empire. Sub-projects sprouted in the Caucasus, Central Asia, and the Arctic. Special weather monitoring aircraft, and 12s fitted with aerosol dispersal pods and radio instrumentation, crisscrossed the skies under strict radio silence. In many regions, ordinary citizens began to notice strange phenomena: glowing night clouds, thunder without storms, sudden rains that fell from cloudless skies. Local officials dismissed these as imagination. But in secret briefings, the Ministry of Agriculture filed increasing numbers of damage reports: flooded valleys, dead livestock, power surges caused by unexplained atmospheric electricity. Still, the party demanded results. Each apparent success, an unexpected rainfall, a diverted storm, was heralded as proof that Soviet science had conquered the final frontier. Internal bulletins declared, "Weather is no longer the enemy of progress." But within Cyclone's laboratories, some began to wonder whether the atmosphere was fighting back. Instruments malfunctioned, sensors overloaded, and temperature gradients behaved unpredictably. As one engineer wrote in a classified field journal, "We are pulling levers we do not yet understand." The data grew increasingly erratic. Patterns appeared, then vanished. What had begun as control was dissolving into chaos. But before anyone dared to stop, another order arrived from Moscow, one that would take Project Cyclone to its most ambitious and dangerous phase yet: the creation of storm factories, entire installations dedicated to producing weather on demand. By 1972, Project Cyclone had evolved from laboratory tests into a colossal enterprise stretching across the Soviet Union's most extreme landscapes. What began as scientific curiosity was now a matter of national policy, cloaked in secrecy and driven by ambition. The Politburo demanded supplied results, and the scientists, eager, exhausted, and increasingly uneasy, set out to build something the world had never seen: installations capable of manufacturing storms. They called them storm factories, though the term never appeared in any official document. To the public, they were regional meteorological research stations. To those who worked there, they were experiments in controlled chaos. The first was constructed in the arid plains of Uzbekistan, near the vanished shoreline of the Aral Sea. Rows of towering metal pylons stretched toward the horizon, each fitted with release valves, ion generators, and radar dishes aimed skyward. The complex pulsed with a constant electric hum, as if the Earth itself were charging for a strike. The plan was deceptively simple: heat the lower atmosphere to create upward convection, seed the rising air with fine particulate matter, and then charge the surrounding clouds using massive ionization fields to force condensation. In theory, the result would be artificial rain. In practice, it was unpredictable, violent, and often terrifying. The first full activation, recorded in July of 1973, produced a localized thunderstorm that raged for hours over the empty desert. Engineers cheered as the first drops fell, then watched in disbelief as gale-force winds tore through their own facility, toppling towers and scattering instruments like straw. One technician described the scene in his report: "We built a storm, and it obeyed no one." Still, the experiment was deemed a success. Rain had fallen where none was forecast, and that alone was proof enough for Moscow. Within months, new storm factories were planned across Central Asia and Siberia. Each facility had a distinct focus, some on snow generation for water reservoirs, others on redirecting monsoon flow toward drought regions. A facility near Irkutsk attempted to induce snowfall over Lake Baikal to restore glacial accumulation. Another, hidden deep in the Pamir Mountains, experimented with large-scale thermal pulses using jet engines mounted on concrete platforms, blasting hot air upward to create turbulence. The noise carried for miles, and local villagers whispered that the mountains have begun to breathe fire. The work attracted attention beyond the USSR. Western satellites detected unusual patterns, large circular clearings in the clouds, strange temperature anomalies, and rhythmic pulses of radio interference. American analysts debated whether these were weather experiments or tests of new radar jamming technologies. Inside the Pentagon, a handful of strategists even suggested that the Soviets might be weaponizing climate. The irony was lost on few. By this time, U.S. forces in Vietnam had been conducting their own rainfall-inducing operations under Project Popeye, now publicly exposed and internationally condemned. Both sides were chasing the same forbidden idea: victory through nature's machinery. Back in the Soviet Union, the toll of cyclones' expansion was mounting. The enormous power requirements strained regional grids. Accidents multiplied. One facility near Omsk suffered an explosion when an ionization tower overloaded, sending a blue-white arc through its generator halls. 2 engineers were killed instantly, their instruments fused into molten shapes. Official reports attributed it to equipment malfunction due to weather interference, a phrase so absurdly circular that even party investigators hesitated to question it. Yet for every failure, the propaganda continued. News bulletins spoke of successful atmospheric irrigation, and magazines printed heroic images of scientists standing proudly beneath stormy skies, lightning etched behind them like a banner of progress. The truth, however, was that no one could predict what each activation might bring. Some operations yielded gentle rain, others unleashed flash floods. In one notorious 1974 test in Kyrgyzstan, a supposed snow enhancement trial triggered an avalanche that buried an entire mining camp. Survivors were forbidden to speak. The scale of secrecy was astonishing. Workers were rotated frequently to prevent leaks, and entire villages near testing zones were temporarily relocated under vague explanations of hydrological safety. Only a few at the top knew the full scope of Cyclone's ambitions. Internal documents described a future in which agricultural and military meteorology will merge into a unified atmospheric management network. It was an empire built not on soil or steel, but on air. By the mid-1970s, Project Cyclone's achievements were as unstable as the weather it sought to control. The state had invested millions, yet the data refused to cooperate. Patterns emerged only to vanish, equations dissolved into contradiction, and computers, still primitive by modern standards, could not keep pace with the chaos of the sky. Boudico himself, once the project's prophet, began to retreat from its extremes, warning that a system as vast as the atmosphere cannot be mastered by command. But his warning came too late. The machinery was already in motion, and the state, hungry for proof of supremacy, demanded another demonstration. This time, the goal would not be rain or snow. It would be something grander, and infinitely more dangerous, to test how far human influence could reach into the planetary engine itself. By 1975, the Soviet Union had built more machines for shaping weather than any other nation on Earth. Dozens of storm factories hummed across the steppe, their ion towers crackling under the grey sky. Yet for all the triumphal rhetoric, results remained erratic. Some regions flooded, others starved for rain. Each success seemed to create two new problems elsewhere. Frustrated officials demanded a deeper understanding of the upper atmosphere, and in the logic of the Cold War, deeper understanding meant larger experiments. At that same moment, the USSR's nuclear program was reaching its own zenith. The Semipalatinsk test site in Kazakhstan had hosted over 400 detonations, both above and below ground. These explosions created their own miniature climates, shock waves that displaced clouds, dust that circled the globe, and radioactivity that attached to raindrops. To the scientists of Project Cyclone, the proximity of nuclear tests was not a coincidence but an opportunity. If atomic detonations could disturb the atmosphere, they reasoned, then controlled releases of energy might provide insight into the ultimate mechanism of weather itself. The cooperation began quietly. Cyclone engineers were granted restricted access to data from the Ministry of Medium Machine Building, the agency that oversaw nuclear weapons research. Their task was to measure how energy from explosions affected air pressure, humidity, and ionization levels. A handful of atmospheric physicists, sworn to secrecy, stood on observation towers as mushroom clouds bloomed on the horizon. They recorded barometric tremors, tracked the curling ascent of dust columns, and watched as artificial rain fell hundreds of kilometers away. The correlation between nuclear tests and subsequent weather shifts was impossible to ignore. Soon, the two programs began to blur. Reports from the Semipalatinsk range described joint experiments, low-yield detonations timed to coincide with weather modification flights. Cloud-seeding aircraft circled the blast zones, releasing silver iodide into the radioactive plumes to study how fallout interacted with condensation nuclei. Some of the resulting storms glowed faintly under moonlight, their rain contaminated but eerily beautiful. Soldiers who worked in the test areas later recalled metallic-tasting water and strange burns on exposed skin. Officially, none of this existed. The archives simply refer to ion experiments conducted under controlled conditions. In Moscow, the the data painted a picture as fascinating as it was frightening. The introduction of energy, whether electrical, thermal, or nuclear, undeniably influenced cloud formation and atmospheric motion. But it also produced uncontrollable feedback loops. Radioactive aerosols altered the electrical conductivity of the air, amplifying lightning and turbulence. Instruments malfunctioned, sensors gave conflicting readings, and several aircraft were lost in the ensuing storms. One crashed near Lake Borkhash, its crew declared missing. Recovery teams later found twisted wreckage half buried in salt flats, instruments still humming faintly from residual charge. The ethical boundaries of cyclone were disintegrating. Some scientists privately questioned whether the experiments were worth the risk, warning of long-term environmental consequences. Their concerns found no audience. In the hierarchy of Soviet ambition, moral hesitation was indistinguishable from sabotage. Instead, the party promoted the effort as a dual-use triumph of science and defense. A 1976 internal bulletin claimed that the harmonious cooperation of nuclear and meteorological technology secures the motherland against any climate manipulation from abroad. But the harmony was illusion. The cumulative interference from repeated detonations began to distort regional weather cycles. Summer thunderstorms arrived months late, rivers swelled without rain, dust storms struck areas that had never seen them before. Farmers complained that the seasons had become erratic, that their planting calendars no longer matched the land. The Ministry of Agriculture quietly compiled these reports but suppressed publication. To admit that human intervention had destabilized the climate was unthinkable. Then came the catastrophe. In late 1977, during an attempt to combine a subnuclear blast with ionization towers near the Caspian Basin, the experiment spiraled out of control. Instruments overloaded, lightning struck transmission lines, and a chain of short circuits triggered fires across the installation. For hours, the facility burned beneath black clouds that rained oily residue over nearby villages. The official explanation cited industrial malfunction due to abnormal meteorological phenomena. In reality, cyclone had set the sky ablaze. Afterward, Boudico and several senior researchers pleaded for the program's suspension. They argued that continued interference risked unpredictable consequences at continental scale. Their pleas were ignored. The experiment's data, classified as meteorological defense intelligence, was sealed. Boudico resigned soon after, his warnings buried in archives that would not surface for decades. From that point onward, Cyclone no longer existed on paper. Its facilities were absorbed into the Ministry of Defense, its scientists reassigned under new titles. The work continued, but in silence, deeper and darker than before. For the Soviet Union, the pursuit of climate control had become inseparable from the pursuit of power. Yet even as the machinery rusted and the towers fell quiet, a new realization began to dawn among those who remained. They might have changed more than the weather. They might have changed the planet itself. By the late 1970s, the empire that once promised to master the sky was running on fumes. The storm factories that had once buzzed with energy stood half abandoned, their towers corroded by the very elements they were meant to command. Wires dangled like vines across deserted compounds, their generators cannibalized for parts. What had begun as Stalin's dream of dominion and Khrushchev's campaign of optimism was dissolving under Brezhnev's cautious, bureaucratic gloom. The Soviet Union was tired, and so was its weather machine. The official report still spoke in triumphal tones. Internal bulletins declared that the methods of atmospheric regulation continued to yield valuable agricultural results. In reality, the data was incoherent. Decades of experiments had left behind a labyrinth of contradictory findings, missing logs, and unexplained anomalies. Rainfall patterns across Central Asia had shifted in unpredictable ways, drought struck regions that once flourished, while new lakes appeared where none had existed. Scientists quietly began to suspect that the very experiments meant to stabilize nature had instead destabilized it. Boudico, now a marginal figure after his resignation from Project Cyclone, watched from the sidelines as his life's work crumbled into myth. He lectured occasionally about the fragile equilibrium of planetary systems, his tone no longer prophetic but remorseful. In one interview, later censored, he warned that we sought to command the climate, but in truth, we never understood it. For the first time, the party allowed silence to replace propaganda. Even the most loyal officials sensed that the weather had become an unsafe topic. Meanwhile, out in the field, the remnants of Cyclone lingered. Some installations still operated under the guise of hydrological research. Technicians monitored aging radar stations and rusted ion towers, submitting meaningless data to offices that no longer read it. The younger generation of meteorologists, trained on computers and satellite imagery, regarded the old experiments as relics of a bygone superstition. Yet even they felt the weight of what had been attempted. "We inherited ghosts," one researcher later said. "The atmosphere keeps the memory of what we did to it." Then came a series of strange seasons that no one could explain. The summer of 1978 brought weeks of static haze across western Siberia, visible even in satellite images. Instruments at the main geophysical observatory recorded abnormally high concentrations of charged particles in the upper atmosphere, but the readings defied calibration. A year later, the Volga Basin suffered flash floods following unseasonable thunderstorms that formed out of clear skies. Old scientists whispered of cyclone's residue, atmospheric scars left by years of chemical and electrical interference. Officially, these were dismissed as natural fluctuations. Unofficially, some wondered if nature was reclaiming its balance. Within the Kremlin, Brezhnev's advisors had grown wary of scientific grandiosity. The failures of space agriculture, ocean mining, and now weather modification all carried the same lesson: ambition without control led only to embarrassment. Project Cyclone's remaining budget was quietly absorbed into other ministries. By 1980, its name disappeared from state ledgers altogether. No announcement marked its end, it simply faded into bureaucratic dusk. The scientists dispersed, some to universities, others to secret defense projects where their expertise in atmospheric modeling found new, more discreet uses. Yet the legacy of those experiments could not be erased. A handful of classified documents survived: test logs, photographic plates, and fragments of correspondence, enough to hint at the scale of what had been done. When the Soviet Union began to falter in the 1980s, rumors of weather weapons and electric towers in the steppe resurfaced in Western intelligence circles. Most analysts dismissed them as Cold War paranoia. But a few noticed correlations: strange cloud formations over Kazakhstan, unexplained shifts in jet stream behavior, radiation readings inconsistent with known tests. Inside the USSR, ordinary citizens told their own stories. Farmers remembered the summer when rain fell metallic and bitter. Pilots recalled sudden bursts of static that shut down instruments mid-flight. Fishermen on the Caspian spoke of nights when the sea glowed faintly beneath clear skies. To the outside world, these were anecdotes; to those who lived beneath them, they were the echoes of a forgotten war against the weather. By 1982, even the last storm factory near Novosibirsk had gone silent. Its fences sagged, its watchtowers unmanned. Grass grew through cracked asphalt where trucks once hauled drums of aerosol chemicals. The scientists were gone, but the silence they left behind carried its own gravity. It was not the silence of victory, but of surrender, the quiet recognition that some forces will never obey command. The era that began with Stalin's promise to master nature ended not with a discovery, but with a whisper. No speeches, no decrees, only the slow realization that the empire's reach had exceeded its understanding. And yet, even in decay, Project Cyclone refused to vanish completely. Beneath the archives and ruins, fragments of its data endured, fragments that would, decades later, resurface in another world entirely, under another government, searching for answers to the same question: can the weather be controlled? The Soviet Union would collapse before that question was ever answered. But the sky, restless, charged, and unpredictable, remembered everything. When the Soviet Union finally disintegrated in 1991, most of Project Cyclone's archives were either destroyed or hastily boxed away in unmarked warehouses. Entire departments vanished overnight, their research reassigned, misfiled, or simply forgotten. What survived was fragmentary, a few reels of film showing towers discharging into the clouds, water-stained logbooks filled with shorthand notations, and scattered pages stamped, "Top Secret." They told no single story, only the outline of a vast ambition that had outlived its masters. Yet as the Iron Curtain fell, that ambition began to echo once more, this time as myth. Journalists in the early 1990s stumbled upon references to Project Cyclone in declassified budget reports. Western tabloids turned the fragments into legend, tales of Soviet weather weapons, ion cannons buried in the steppe, and artificial hurricanes conjured to punish rebellious provinces. The truth, as always, was less cinematic and more unsettling. The Soviet scientists had not built gods of thunder or machines of destruction. They had built instruments of uncertainty, machines that revealed how fragile the balance between science and hubris could be. Still, the myth spread faster than the data ever had. Television documentaries whispered about geoengineering before the term existed. Conspiracy theorists blended fact and fantasy, linking Soviet experiments to American ones, HAARP in Alaska, cloud seeding operations in Vietnam, microwave transmitters in the Arctic. They spoke of global elites owning the weather, unaware that decades earlier, real scientists had already tried, and failed, to do exactly that. Cyclone's legacy became a mirror for modern fears, that somewhere, someone still pulls the levers of the sky. In Russia, the silence persisted. Many of the surviving researchers retired into obscurity, their pensions modest, their memories guarded. Some refused interviews entirely, while others offered only cryptic remarks. One elderly physicist, when asked whether weather control had ever truly succeeded, smiled faintly and replied, "We succeeded in proving it cannot be controlled." Another confessed that the greatest secret of all was not the machines, but the realization that even small experiments could alter the world in ways no model could predict. By the turn of the millennium, traces of Cyclone's infrastructure still dotted the landscape, rusted pylons half swallowed by weeds, abandoned bunkers humming faintly from residual power, and radar dishes pointed eternally toward empty skies. Satellite images of Central Asia showed geometric clearings that puzzled analysts, symmetrical rings in the desert, too precise for erosion, too meaningless for architecture. The locals had their own explanations. Some called them lightning fields, others the places where the clouds were chained. Meanwhile, the science had come full circle. Around the world, nations once again began exploring weather modification, not as weapons, but as tools against drought and climate change. Silver iodide flares lit up the skies over China and the United Arab Emirates. Research papers spoke openly of climate intervention and radiative forcing. To the public, these were new frontiers. To history, they were repetitions. Every generation rediscovered the same temptation, that perhaps, with just enough data and power, the atmosphere could be persuaded to obey. And yet, Cyclone's ghost lingered in the scientific conscience. Its legacy became a warning whispered in policy meetings and ethics boards that nature is not an enemy to defeat, but a system too vast to command. The Soviet Union had learned that lesson through silence, through the ruins of its laboratories, and through skies that refused to behave. The tragedy of Project Cyclone was not its failure to control the weather, it was its success in proving that such control could never be innocent. Today, the wind over the Kazakh plains still moves unpredictably, shifting dust over forgotten concrete slabs. The towers are gone, the circuit's cold, but on certain nights, the air carries a faint metallic scent, like ozone after lightning. To those who know the story, it feels less like coincidence than memory, the atmosphere remembering its own manipulation. History, like weather, is never truly still. The clouds above us remain the same that drifted over Stalin's Moscow, over Brezhnev's silent fields, over the scientists who believed they could command the sky. Their machines are gone, their archives sealed or lost, but the question they asked still hangs, unanswered, in the air. If humanity could control the weather, would we ever stop? And perhaps, somewhere in the shifting winds of Central Asia, the sky itself whispers back, never again. For a brief moment in history, men believed they could engineer the climate, rewrite the seasons, and master the chaos of nature. They discovered instead that the atmosphere has no master, only witnesses. The story of Project Cyclone is not just about science or secrecy, it is about the enduring human desire to command what cannot be commanded. If you found this story intriguing, watch another episode in this series. Each file reveals another chapter in humanity's hidden history. Don't forget to subscribe so you don't miss the next descent into the archives of power, secrecy, and forgotten ambition.